Good morning. We are starting back with our videos. I am on number 18, and the directions on number 18 say to solve by completing the square. And so you are going to need to solve this by completing the square. Now, this particular problem can be factored. So it's not inappropriate to look at how this would work factoring. So we've got x squared plus 8x plus 12 equals 0. Our sum is 8 and our product is 12. So 2 times 6 is what gives us 12, and 2 plus 6 gives us 8. So I have x plus 2 and x plus 6 equals 0. I set each one of those equal to 0. And so my answers are x equals negative 2 and x equals negative 6. So our goal is, when we complete the square, is to get these same answers. And using the factoring method to see what our answers would be is appropriate. So what I'm going to do here is our first step in completing the square is I am going to take the 12 and I'm going to move it over. And I do that by subtracting 12 from both sides. So I have x squared plus 8x equals negative 12. Okay? Then my next step, and this is what sometimes confuses students, I need to take half of this value right here. So I have 8, and I need to take half of that. So half of 8 is 4. And then I'm going to square that. So 4 squared is 16. And that is what I add to both sides. So I add 16 to both sides. Okay, at this point, we can simplify. So I have x squared plus 8x plus 16, and that is a perfect square trinomial by design. We wanted that to be a perfect square trinomial. When we are completing the square, what we are creating is perfect square trinomials. This can be factored, okay? X squared plus 8x plus 16. It can be factored because it is a perfect square trinomial. The numbers that we're looking for are 4 and 4, because x plus 4 and x plus 4 is going to give us x squared plus 8x plus 16. But 4 plus 4 gives us 8, and 4 times 4 gives us 16. Okay? X plus 4 times x plus 4 can be rewritten as x plus 4 squared. Okay? Now our next step is to take the square root of both sides. So I'm going to take the square root of this side, and I'm going to take the square root of this side. But when I take the square root of the right-hand side, I have to include that plus or minus. So now I've got x plus 4 equals plus or minus the square root of 4. Now the square root of 4 can be simplified. So I have x plus 4 equals plus or minus 2. Okay? I subtract 4 from both sides, and I am left with x equals negative 4 plus or minus 2. Now, the danger is that students stop right here. And if it was a complex answer, which had I in it, or it was an answer that had a square root in it, which makes it irrational, then we would stop right there. But we can keep going. This negative 4 plus or minus 2, it means negative 4 plus 2 and negative 4 minus 2. So we can keep going with that. And so you want to. So negative 4 plus 2 is negative 2. Negative 4 minus 2 is negative 6. So our answers to this are right here. Negative 2 and negative 6. And that is exactly what we got when we factored. Okay? So you do have a problem on your final exam that says that you have to complete it using completing the square. So be sure you are completing it this way. Okay? Number 19 says, Maddie weighed 32 pounds when she was 4 years old and 50 pounds when she was 7 years old. Assuming a linear relationship, how much will she weigh when she is 13? So we have to do two things here. The first thing that we have to do is we have to find the function. Okay? We have to find the function that describes Maddie's weight at 4 years old and 7 years old so that we can predict her weight at 13. The second thing that we have to do here is then we have to plug in 13 to find her weight at 13 years old. Okay, so in order to find the function, we're going to find our slope first. We've got to really make sure we understand what's the x values and what are the y values. Her age is going to be my x values. Okay, so at 4 years old, she weighed 32 pounds. Okay, then at 7 years old, she weighed 50 pounds. Okay, so getting the correct ordered pairs is very, very important for solving this problem. So at 4 years old, she weighed 32 pounds. At 7 years old, she weighed 50 pounds. So 4 and 7 are my x values, 32 and 50 are my y values. So I'm going to find my slope. So that's change in y over change in x. Okay, or you can think of it as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so I have 32 minus 50 over 4 minus 7. 32 minus 50 is negative 18. 4 minus 7 is negative 3. So my slope here is going to be 6. So what that's saying is that Maddie gained 6 pounds per year. So my slope is 6. Okay? Now I'm going to have to erase some of that to get to the next part. Now that I've found my slope, what I'm going to do next is I'm going to plug my slope and either point, it doesn't matter which point we use, into point slope form of the line. Okay, so it doesn't matter which point we use. And I'm going to go ahead and use my first point right here. So I have y minus 32 equals 6 times x minus 4. Okay, I'm going to distribute my slope. So I have 6x minus 24. So then I solve for y by adding 32 to both sides. So I have y equals 6x plus 8. Now, what this is actually telling us, if we think about this linear relationship of weight over the course of Maddie from when she was born until when she was 13, this 8 right here is how much she weighed when she was born. That's what that means. Like her starting weight was 8 pounds. And then she consistently gained 6 pounds each year. Now, that's actually not exactly how it works because a baby gains a lot more than 6 pounds in that first year. But the overall function is linear. And so that is where we are. Okay, so I need to erase this part so that we can do the second part, which is how much does she weigh at 13. So we've got to plug 13 into 6. So let's go back here. So we've got y equals 6x plus 8. Okay, we're going to plug 13 in. So I have y equals 6 times 13 plus 8. Now, if you need to do the multiplication off to the side, we have 13 times 6. 6 times 3 is 18. 6 times 1 is 6, plus 1 is 7. Okay, so then we have y equals 78 plus 8. So at 13, she is projected to weigh 86 pounds. Okay, so I am looking for two things. I am going to be looking for this function right here that tells you that linear relationship. And I am going to be looking for this right here, this 86 pounds. Okay? Number 19 says, perform the indicated operations and simplify. And so that's what we're doing here is we're using our exponent rules, and then when we are simplifying our final answer. I want you to look at a couple things right here. The very first thing that you need to look at is you need to look at this 3 on the outside and this negative 3 on the outside. So both of those are outside, and so everything inside those parentheses are being raised to that power. So you must deal with that first. Okay, you've got to deal with each of those first before I do anything else. Now remember, this 3 on the outside, it belongs to everything. It belongs to the 2, it belongs to the b, and it belongs to a to the 4th. So we're going to write 2 to the 3rd power, b to the 3rd power, and a to the 12th power, because when you are raising a power to a power, you multiply. Okay, then this -3 belongs to the b to the 2nd, and it belongs to the a. So we're going to have b to the -6th, because a power to a power we multiply, and a to the -3rd. Okay, so the first thing that you've got to do is you've got to make sure that power that is outside the parentheses is given to everything inside those parentheses. Okay, so then I've got 2 to the 3rd power. 2 to the 3rd power is 8. That's 2 times 2 times 2. So I have 8, b to the 3rd, a to the 12th. Okay, now my b to the -6 goes to the denominator and becomes b to the 6th, because once you move that to the denominator, the exponent becomes positive. The a to the -3rd goes to the denominator, and it also becomes positive. Now, at this point, we can simplify. I have b to the 3rd in the numerator, and I have b to the 6th in the denominator. Okay, think of that as b times b times b over b times b times b times b times b times b. Okay, if it's in the top and the bottom, we can mark it out. So when we do that, we're not going to have any b's left in the numerator. And we are going to have 3, so b to the 3rd power, in the denominator. Okay? A to the 12th over a to the 3rd. All of our a's in the denominator are going to be gone. And then I'm going to be left with 9 in the numerator. So my final answer here is 8, a to the 9th power, b to the 3rd power. Okay? Okay. We're still simplifying on the next one. I have 32, a to the 3rd, b to the 2nd, 4, a to the 6th, b. I'm going to deal with my 32 and 4. 4 goes into both of those. 4 goes into 32 8 times. And 4 goes into 4 1 time. Okay? Then I've got a to the 3rd and a to the 6th. Now, a to the 3rd in the numerator they're all going to be gone because I have more in the denominator. So a to the 3rd, they cancel out completely because remember, it's similar to the one that we just did. We have a to the a times a times a over a times a times a times a times a times a. Okay? And if they're in the top and the bottom, we cross them out. So we're left with a to the 3rd in the denominator. So this a to the 6th becomes a to the 3rd. My b in the denominator cancels. And so then I'm left with b to the 1st in the numerator. So my final answer is 8b over a to the 3rd. Okay? Number 22. It reads, the length of a rectangle is 5 centimeters less than 3 times its width. If the perimeter of the rectangle is 54 centimeters, find the length and the width. So I'm going to go ahead and draw a rectangle. Okay. And then I'm going to go up here and I'm going to kind of do some of the translations. 5 centimeters less. Let's think about how would we write 5 centimeters less? And we would write that by saying minus 5. So the word translation's 5 centimeters less. That's minus 5. And then we've got 3 times its width. So the way that we would write 3 times its width is we would say 3w. So the length of this rectangle is 3w minus 5. And that's 5 centimeters less than 3 times its width. That's how we would represent that. Then we've got, here's my width then. So we've got 3w minus 5 as my length, and my width is just w. So remember, the opposite sides in a rectangle are equal. Okay, so my perimeter is 54. So if I add up the 4 sides, I'm going to get 54. We can use 2 times length plus 2 times width equals perimeter. We can also do length plus width equals perimeter. As long as you account for all 4 sides, you're fine. It doesn't matter which one of those you use. You just have to make sure you account for all 4 sides. Okay? I have a dog that wants to get in my lap right now, so we're gonna ask her not to do that while I'm working. So she's kind of sitting on top of my book. It's very cute. So I'm going to use the top one. 2 times length plus 2 times W equals P. So I've got 2 times my length, which is 3W minus 5, plus 2 times my width, and that equals 54 centimeters. Okay? 2 times 3W is 6W. 2 times negative 5 is negative 10. Plus 2W equals 54. So when I simplify that, I have 8W minus 10 equals 54. I add 10 to both sides and I get 8W equals 64. And when I divide, we determine that the width of this rectangle is 8 centimeters. Okay? So the width right here is 8 centimeters. So now what I do is I go back and I plug 8 in for W. So I have 3 times 8 minus 5. So 3 times 8 is 24, minus 5 is 19. So the length is 19. Now you can go back and check that. You can do 19 plus 19 plus 8 plus 8 to make sure it equals 54. And I would encourage you to go back and check it. But that is our solution. Okay, our last word problem. We did these at the very beginning of the semester. And you are going to use the formula distance divided by time is our rate. Now, if I multiplied both sides of this times t, I would end up with t times r, so that's rate times time, or time times rate, equals d. That's what we end up with. Okay? And that's actually what we're going to end up using here, is this formula right here. The rate times time equals d. So I just want you to understand the relationship between this formula and this formula. We've just solved for something different. So in this particular formula, we have an airplane leaves at noon, or let me read it from the paper. 2 airplanes leave Denver at noon and fly in opposite directions. If one travels at 400 miles per hour and the other at 600 miles per hour, at what time will they be 750 miles apart? Okay, so what we've got to look at is we've got to look at the distance. So if I talk about the distance that plane A travels, and I add that to the distance that plane B travels, then I want to know the time that it takes for them to get 750 miles apart. And that's something we don't know. We don't know the time. Okay, so I can represent the distance of plane A by saying 400 miles per hour times t. Okay, so that's the distance that plane A goes. So it goes 400 miles per hour. If I multiply that times the time that it's traveling, then I have the distance that plane A is traveling. Then I'm going to do the same thing for plane B. So I've got 600 miles per hour that plane B is traveling, and I'm going to multiply that times the total time. We don't know what the time is. But when I do, I'm able to determine that. And when I add these two distances together, then I'm going to get 750 miles. So I have 1,000 t equals 750. Okay, I'm going to divide by 1,000. And when I simplify that, 750 divided by 1,000. Okay, so I can mark out one of these zeros right there, and then I have 75 over 100. If I keep that in fraction form, that is 3/4. Okay, so what I have found is in 3/4 of 1 hour, 3/4 of an hour, these planes are going to be 750 miles apart in 3/4 of an hour. Now, you have to look at your word problem. It says, at what time will they be 750 miles apart? At what time will they be 750 miles apart? They left at noon. So 3/4 of an hour from noon is 12:45 p.m. Okay? And that is your final answer. Okay, so be careful. 3/4 of an hour isn't your final answer. Your final answer is 12:45 p.m. So just read super carefully there. Our last problem. Okay, graph the line using y equals mx plus b form. Identify the slope and the y-intercept. So we're going to do that. We're going to graph the line using y equals mx plus b. So I'm going to go ahead and kind of draw a graph over here for us to use. That's ultimately what we're doing, is we're graphing the line. Okay, before I can do anything, I've got to get it in slope-intercept form. So that means I need to solve for y. I need to solve for y. So I've got negative 3x minus 2y equals 8. I'm going to add 3x to both sides. Okay. And when I add 3x to both sides, I'm left with negative 2y. Don't lose that negative. Lots of students lose that negative right here. So be super careful with that negative right there. Don't lose it. Okay. And then I've got equals positive 3x plus 8. Now, my next step is to divide everything by negative 2. I have y equals negative 3 over 2, or 3 over 2x. So negative, or positive over a negative gives me a negative. So 3 over negative 2 is the same thing as negative 3 over 2. Okay? 8 divided by negative 2 is going to be minus 4. Okay. Now, I need to identify my slope. So my slope here is negative 3 over 2. My y-intercept is negative 4. And that is how I graph this line. So I am going to start at negative 4. So 1, 2, 3, 4. So here is where I start, right here. And then my slope is negative 3. So I'm going to go down 3 and over 2. Okay. I could also go up 3 and to the left 2. Either one of those is completely acceptable. Either one of those. Okay, so now my line looks like this. Oops. Okay, let me just do it this way. There we go. There's our line. Okay, so that is all of the practice test. This practice test, do it as many times as you need to. Do it as many times as you need to. I'll be around this weekend. I'll definitely be around on Monday if you have any questions. I think my office hours on Monday are regular time, 1 to 3. Let me know what you guys need. Good luck.